we now discuss the solution of a problem from the section Differential Calculus. The problem is related to maxima and minima of a given function. This question has appeared in the joint entrance examination main held on 29th June 2022 in the second shift. The given question is, let f be a function from the set of real numbers into itself, and it is defined by f of x is equal to x minus 3 to the power of n1 into x minus 5 to the power of n2, where n1 n2 belongs to the set of natural numbers. Then which of the following is not true? Then which of the following is not true? So we have to identify that option which is not true. Right. We are given 4 options. Option A and option B, option C, option D. 4 options are given to us. In this, the various values of n1 and n2, we have to discuss the local maxima and minima of f. So in the first option, option A, 2 values, n1 is equal to 3, n2 is equal to 4, and we have to talk about the local maxima, minima of the function f at some point alpha belongs to the open interval 3 to 5. For similarly in B, C, D, that means in A, B, C, D, the values of n1 and n2 are varying, and in those contexts you have to talk about local maxima and local minima. At some point alpha belongs to the open interval 3, 5. Right. Let's now discuss the solution of the problem in detail. We have the given function f from the set of real numbers into itself defined by f of x is equal to x minus 3 to the power of n1 into x minus 5 to the power of n2, where n1 and n2 are natural numbers. And to talk about the maxima and minima of any function, we first take its first derivative. So f prime x is equal to, use the product rule of differentiation and write down. So the derivative of the first function, n1 into x minus 3 into n1 minus 1 into the second function, plus first function into the derivative of the second, that is n2 into x minus 5 to the power of n2 minus 1. So we take x minus 3 to the power of n minus 1, n1 minus 1, and x minus 5 to the power of n2 minus 1, the product, as the common factor. Then we write down, then these are the 2 common factors that have come out, and in brackets you will get n1 x minus 5 from the first and plus n2 into x minus 3 from the second. So that is the derivative of, first derivative of the function fx. Right, that is the first derivative we have, and let's call our options one after the other and discuss the local maxima and local minima. So in option A, it is given for n1 is equal to 3, n2 is equal to 4. And we will talk about in this situation where this f attains local maxima or local minima. Agreed. So in the above, put n1 is equal to 3, n2 is equal to 4, then you will get f prime x is equal to x minus 3 to the power of 2, yes, 3 minus 1, x minus 5 to the power of 3, yes, 4 minus 1, right, into n1 is 3 times x minus 5 plus n2 is 4 times x minus 3. So when you simplify, you will get x minus 3 whole square into x minus 5 whole cube into 7x minus 27. So we get the critical points by equating the first derivative is equal to 0. The critical points are x is equal to 3, x is equal to 27 by 7, and x is equal to 5. Agreed. So that is the diagram. So 3 here, 5 there, 27 by 7 in between. Agreed. Now f prime x is written as, this is 7x minus 27 we have written as 7 we have taken out common into x minus 27 by 7 we have written. The other two factors are as it is. Now we will talk about local maxima and minima. In the question it is given that it arises, that it attains local maxima or minima at some point between 3 and 5. Therefore, we discuss the behavior of f prime x, in the interval 27 by 7 to 5 and 3 to 27 by 7 only. That is sufficient for us. So, in the interval, open interval 27 by 7 to 5, x minus 5 is negative, yes, and the two are positives, and it is negative to the power of cube, it is negative. Agreed. And when you take a point between 3 in the interval 3 to 3 in the interval 3 comma 27 by 7, the open interval, this is negative, negative cube is negative, and this is negative, negative into negative positive, but this is positive, so this is positive. Agreed. So that means at 27 by 7 the local maxima will be there. So it's positive and then negative, so therefore it increases and then decreases. So the maximum is attained at 27 by 7, which lies between 3 to 5. That alpha is 27 by 7. So f attains local maxima at alpha is equal to 27 by 7 belongs to 3 comma 5. It attains local maxima, and the option is also given local maxima it attains. So the option A is true, but we have to find out that option which is not true. Agreed. So then we go for the next option. Option B. In this, n1 is equal to 4, n2 is equal to 3. We have to talk about local maxima, minima at some point in between 3 to 5. Agreed. So substitute n1 is equal to 4, n2 is equal to 3 in the above f prime x. Then you will get f prime x is equal to x minus 3 whole cube, right? 4 minus 1. X minus multiplied by x minus 5 whole square, right? 3 minus 1, right? 4 times x minus 5 plus 3 times x minus 3. So the three factors are x minus 3 whole cube into x minus 5 whole square into 7x minus 29. Thus we get the critical points 3, 5, 29 by 7. Those are the critical points we get. Right. Let's look at the diagram. So 29 by 7 lies in between 3 to 5 and f prime x is here. Now we discuss the maxima, local maxima, minima only at 29 by 7. Therefore, we discuss the behavior of f prime x in the open interval 29 by 7 to 5 and the interval 3 to 29 by 7. Agreed. So let's take in the interval 29 by 7 to 5, x minus 5 is negative, but there is a square, it is positive. This is positive, and this is positive. Agreed. In the interval 3 to 29 by 7, x minus 5 is negative, but it's a square, it's positive, but x minus 29 by 7 is negative, but this is positive. So this is negative. Agreed. That means f prime x decreases and then increases. That means fx attains its minima at 29 by 7. That is your alpha. So f attains local minima at alpha is equal to 29 by 7 belongs to 3 to 5. And we have obtained local minima. In the option also local minima is given. So the option B is true. but we have to find out that option which is not true. Let's get into the option C. In the option C, we are given n1 is equal to 3, n2 is equal to 5. We have to discuss local maxima, local minima at some point alpha that belongs to 3 to 5. So substituting these values, n1 is equal to 3, n2 is equal to 5 in the f prime x, in the above f prime x, we get f prime x is equal to x minus 3 whole square, yes, 3 minus 1, x minus 5 whole to the power of 4, yes, it is correct, 5 minus 1, and 3 times x minus 5 plus 5 times x minus 3. So we get 3 factors, and x minus 3 whole square, x minus 5 whole to the power of 4 into 8x minus 30. Yes. So thus we get the three critical points, 3, 5, 30 by 8. And 30 by 8 lies in between 3 to 5. So 30 by 8, 3 to 5 is here. So our f prime x is written as 8 times of x minus 30 by 8. From 8x minus 30 we have taken out a 8 common. So x minus 3 whole square into x minus 30 by 8 into x minus 5 to the power of 4. Agreed. Now let's discuss the behavior of the f prime x in these intervals. And in the interval 30 by 8 to 5, x minus 5 is negative, but it is a fourth power, it's positive, and the 2 factors also will turn out to be positive. So it is positive. And in the interval 3 to 30 by 8, this is x minus 5 is negative, but to the power of 4 is positive, but this is negative. Yes, this is positive, this is negative. Agreed. So that means the local minima is attained for the function f at alpha is equal to 30 by 8 that belongs to 3 to 5. So f attains local minima at alpha is equal to 30 by 8 that belongs to 3 to 5, and in the option C it's also given that it attains local minima, local maxima. So in the option C it is given local maxima, but we have got local minima. Therefore the option C is not true, and we have to find out that option which is not true. Thus we got option C is not true. Agreed. That's our answer. You can check the option D. That will also turn out to be that option D will be true. We stop here. So the answer for this question is option C, because we have to find out that option which is not true. So this is option C is not true. So that is the detailed discussion of the solution of the problem from the section differential calculus, which is related to the maxima and minima of a given function. It is definitely little lengthier, but it is a very easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.